What's the relation between frequency, length, and tension? Okay, we ain't. What's the relationship?
I'm equals to root T over L. N equals to K root T over L.
I owe you something. That is very correct. Please clap for Precious. Clap for Precious now. I don't know the formula. Now the formula is not in your book now. Not the formula. F1. So this is the formula we're applying. So from the parameters given, we can say 400 L1 over what? Root T1 is equals F2 then 2L1 over what? Root 41. So this one can be written as 400 L1 over root T1, which is now equals 2F2 L1 over 2 root T1. Am I wrong? Are we together? Precious, are we together? So from here we can say, which one can cancel out? L1 can cancel out, have you? Do you believe? Don't worry. Don't let me scatter it. Let's cross multiply. So we have what? We have 400, yes, L1 times what? 2 root T1. Is that equals what? 2F2 L1 times what? Root T1. Remember we're looking for F2. Hello, no noise. So we have what? Divide both side by what? 2L1 root T1 over what? 2L1 root T1. So this one. So we have F2 now to be equal to what? 2 and 2 having. So we have what? 400 what? You got it? So why is Chika now complaining? You guys know. I don't know the formula. You are not in class. No, not for people that like. For easy understanding now, some people they'll still ask question. How did this one cancel this one? So to avoid long story. All right, I think that will be all for. Yes, ma'am. Yes, from scalars and vectors. Listen, so this is at the last one that should we take classification of music instruments? Hello? Should we take classification of musical instruments or we should go into vectors directly? Okay, vectors.
So, like, your options don't sound good.
Yes.
Chika,
Yes, sir.
let's continue laughing.
Now everybody, sorry. You should be the only one to do the talking. Nobody should say anything unless you have a question to ask. Okay, you go shaka. Go get down on what is coming. That is all. Do you hear?
Yes.
Once I come back and I hear the issue is very much.
Okay, theory of vectors. Hope we are done with this. Theory of vectors, shall we? Alright. There are two divisions of physical quantities. There are two divisions of physical quantities. And these are scalar quantities and vector quantities. These are scalar quantities and vector quantities, comma, whereas a quantity is a measurable entity. Whereas a quantity is a measurable entity. So what is scalar quantity? Yes, anybody? Barbarians talk in thousands. Just signify. Alright, a scalar quantity, a quantity with only magnitude but no direction. So another name for the magnitude is what? Yes. If you don't want to use the word magnitude, what will you use? DJ BBO, IBBQ. Sit up. If you don't want to use magnitude, you make use of size. Yes. So a scalar quantity has only size. So you can put down your own definition. Scalar quantity is a quantity that has only magnitude but no direction. So you just write it the way you want it. But a scalar quantity has only size, put in brackets magnitude. And examples are speed. Pressure, speed, pressure, volume, density. Yes, density. Electric potential. Area, distance. area, distance, and all fundamental quantities.
So there's mass.
All fundamental quantities. What's the abbreviation I gave you guys last year? For those of you that were around. For fundamental quantities. All fundamental quantities. If like, look at it there.
I was not part of them.
You cannot be part of them.
Exactly. No.
Meanwhile, yele. Bokwin. All right. I said all fundamental quantities. So what are the fundamental quantities? I gave an abbreviation. I've been using that abbreviation for years, and this is it. Fundamental quantities. M for mass, L for length, T square, that's time and what? Temperature. A, amount of substance, L, luminous intensity, and E is for what? Energy. Electric current. So we also have work energy power as part of scalar quantity, work energy and power. Then specific heat capacity. Specific heat capacity. Specific heat capacity. Vector quantities. So what are vector quantities? Yes?
Yeah, quantities that have both magnitude and direction.
All right, put that down. Vector quantities are described in terms of size or magnitude and direction. At front of the direction, put angle in brackets. Examples of vector quantities include
Displacement.
yes, displacement, velocity, acceleration. Join the class now. Why are you staring? Join the class. Displacement, velocity, acceleration, electric field, magnetic field, force, temperature gradient, force, temperature gradient, etc. A vector can be specified by using O as its projection component. By using O. as its projection component. Components. Projection components. Yes, ma'am. So we have something like this. Hello, no noise. This is y, this is x, and this is z. So we have ay here, ay as in Ayomide, az as in Azizat, then ax as in Alex. So the resultant of these vectors will now be vector A will equals ax, comma, ay, comma, az. So instead of having just two planes, now we have how many planes? How many planes? 3 planes. And which are what? X, Y, and what? Z. So now, this vector can also be written as I, J, and K. So resultant vector can also be written as AXI, comma, or let's say plus AYJ plus AZK. Can I rub the other side off? So now for two components, which is your what? X and Y, the resultant is usually resolved as X and Y, two components. That's how many dimensions? X and Y. That's how many dimensions? 2 dimensional. So it is used. We can use the Pythagoras formula. What's the Pythagoras formula?
6 square.
C square is equals A square plus B square. So in in 2 dimension, having X and Y, having something like this, we can say we have A square plus B square is equals C square, which is same as this. Or we can say this one. No, wait, let's do it like this. For 2 dimension, we have R. Assuming this is the first one, which is R1 square plus what? R2 square. So it will now be the root of this, Abby. Is there any question? It's just the application of what? Pythagoras theorem. And when it comes to this, we can say this one will be what? Vector A will be equals to what? Square root of what? Ax square plus what? Ay square. That's in 2 dimensions, and the first 2 dimensions, which are x and y, is replaced by what? I and g. I and g. So now for 3 dimensions, what will this be resolved as? Yes, the resultant. What would the resultant be? So the resultant vector will be what? It's what? Ax square plus what? Ay square plus az square. It's not as easy at all. So this will now be in what? In I, J, and what? And K. Is there any question so far? Please let me with that brochure. So we can put this down. Put it down. Let's move to definition of terms. Definition of terms. Terms ne purpose mean. So the first one we'll be talking about is null vector. Null vector. Null vector. Null vector. What do you understand by the word null? Null. No vector. So put this down. This is a vector. This is a vector. This is a vector in which this is a vector in which both initial points, this is a vector in which both initial point and the terminal point and the terminal point fall together or happens simultaneously. Both initial point and the terminal point fall together or happens simultaneously.
How do I speak like this? Like that yes, my side.
The next one, unit vector. Unit vector. This is a vector. Unit vector. This is a vector. This is a vector that have one length. This is a vector that has one length. That has one length. The third one, collinear vector. Collinear vector. Vector. Collinear vector. This is a vector. This is a vector. This is a vector that is parallel to one another. This is a vector. This is a vector that is parallel to one another. The next one, coplanar vector. Coplanar vector. Coplanar vector. coplanar vector. This is a vector. This is a vector that lies on the same plane. This is a vector that lies on the same plane. This is a vector that lies on the same plane. Plane, P-L-A-N-E, plane. The next one is position vector. Yes, position vector. Position vector. Position vector. This is a vector. This is a vector. This is a vector that starts from the origin. This is a vector that starts from the origin. The next one, equal vectors. Equal vectors. Equal vectors. This is a vector. This is a vector that has same size, put in bracket magnitude. This is a vector that has same size, put in brackets magnitude, and the same direction, and the same direction, and the same direction, put in brackets angle. This is a vector that has the same size, put in brackets magnitude, and the same direction, put in brackets angle. Conditions for equality of vector. 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 Vector A is said, right, conditions for equality of vector. Vector A is said to be equal to vector B when 1. One, they are parallel. They are parallel. 2, they are in the same direction. 2, they are in the same direction. 3, they have the same magnitude. They have the same magnitude. They have the same magnitude. And 4, may produce different principal effects. 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 May produce, reproduce ní kọ́kọ́. We in biology class. May produce different principal effects. Now, another subtopic, vector operation. Vectors operation. Vectors operation. Vectors operation. So the first one we'll be talking about is addition of vectors. Addition of vectors. Addition of, hello, addition of what? Vectors. Addition of vectors. There are two ways by which vectors can be added. There are two ways by which vectors can be added. One, we have using the parallelogram law. I hope we all know the parallelogram law. I hope we all know the parallelogram law. Are we all familiar with parallelogram law? Only one person in class. Are we all familiar with parallelogram law? Work on room sweet gents here. Shake in Agatilo one. Are we all familiar with parallelogram law? Assignment 1. Assignment 1. Write out and memorize parallelogram laws of vectors. Write out. Assignment 1. Write out and memorize parallelogram law of vectors. Write out and memorize parallelogram laws of vectors. Parallelogram laws of vectors. So by using parallelogram law, 2, by using addition of components. By using addition of components. So we'll be focusing on using of addition of components. Addition of components. So put down this question. Put down this question. Can I rub this up? Hello?
Yes, sir.
All right. If two vectors hello, if two vectors have the components as follows. If two vectors have the components as follows. Vector A, we have 3i plus 2j plus 4k. Do you remember why we are using I, j, and k? Why are we using I, j, and k? Why are we using I, j, and k? Thank you, because it is in 3 dimensions, and which are x, y, and z. Are we together? So now for B, now we have vector B to be equals AI, it's not germanium, plus BJ plus CK. Now you have to find A plus B. So now to get A plus B, hello, pay attention, stop writing. Though this is the introductory aspect. I know that one having pink band will not stop. But to wá jẹ́ ká máa lọ́mọ òkú sí, àmọ́ bọ̀ yẹn lọ́mọ òkú. Oh, but your best teacher in secondary school is Mr. Kukwala. Are you sure? Alright. So look at this now. What we're going to do is that we are going to pick out the components individually. So for A plus B now, A plus B plus B, we have 3I plus what? AI plus what? Plus CK. So now what will we do? We'll bring out this, the component I. We have 3 plus A, Abi, plus J, Abi, 2 plus K, we have what? 4 plus C. So this is the addition of the component. Now let's move further to having another different example. This is the addition of the component. So A plus B will give us this. A plus B will give us this. This is example 1. Now example 2. Put this down. Example 2. You have already dashed them your cap. Alright. Are we done with this?
No.
Example 2. If vector Q is equals for I plus J plus 3K and P, vector P is equals I plus 8J plus 6K. Find Q plus P. So now this one is also easy. Pay attention. So Q plus P, you bring out the components, which will now be what? 4I plus I plus J plus 8J plus what? 3K plus 6K. So what do we have here? I open bracket 4 plus 1 plus what? J into bracket 1 plus 8 plus K into bracket 3 plus 6. So what do we have? We have what? 5I plus 9J plus what? 9K. So this is the resultant. This is the addition, sorry. So the addition is this. Any questions so far? Now, example 3. Are we done with this? Yeah, write this down.
I've not seen, like, I don't think I've seen a question like this at the conversation before.
Prep yourself. Prep yourself. Don't let it catch you unawares. I've seen something like that before. Don't let it do what? Catch you unawares. Example 3. Still, this question is for you. Yeah, go.
What do you want to do?
Go now. Example 3. What vector v what vector v must be added to two vectors?
No, I don't want to.
What vector v must be added to two vectors p, which is equals 2I plus 3j.
What vector?
Yes, what vector v must be added to two other vectors? In which the p is 2I plus 3j and q is equals 2I plus 4j. I say what vector v must be added to two vectors? P, which is the first one, 2j plus 3j, and q, 2I plus what? Sorry, this one is 2I plus 3j. P is 2I plus 3j and q is 2I plus 4j. To give a resultant vector, R, which is equals I plus 2j minus 3k. I plus 2j minus 3k. How do we answer this question? Yes. Say what vector v must be added to p and q to give resultant vector this and this. So what they are trying to tell us is that what? Hello, pay attention. Omo Igbo. Omo Igbo. So what our question is trying to tell us is that p, hello, plus q plus v will give us what? R. Abi? And we don't know v, right? But we know p and q. We also know r. So what do? We say make v the subject of the formula. R minus what? Minus p minus q. Abi? So what do we have here? We have v will now be equals to, what's our r? I plus 2j minus 3k minus what's p? 2I plus 3j and q. 2I plus 4j. So what do we do here? We say v is now equals to I plus 2j minus 3k minus 2I minus 3j minus 2I minus. Are we together? Don't let this confuse you. How are you confused? Why? It's the minus now. The minus open the bracket. Abi? Minus times, there's invisible plus here. Minus times that plus, we have minus. Minus times another plus here, we have what? Minus. Minus times plus. Minus times plus. Minus. As simple as that. No big deal. Are we together? Yes. So now what do we do now? We collect what? Like terms. So we say our V is equal to what? I minus 2I minus 2I plus what? 2J minus 3J minus 4J minus 3K. 3,000 naira. 3K. Urgent 3K. So we have what? V to be equal to what? Now minus 2I minus 2I, we have what?
Okay, minus 4.
Minus 2I minus 2I, we have what? Minus 4I. So 1 minus 4I, we have what? Minus 3I. Then minus 3J minus 4J, we have what?
Minus 7J.
Minus 7J plus 2J, we have minus 5J. Then what else? Minus 3K. So the result, the vector we are looking for that will add up to give us this resultant vector is minus 3I minus 5J minus 3K. As simple as that. Is there any question? Any question?
Yes.
Yes. What's your question, Chika?
So one vector must be added to two vector P. Why is the vector P not 2?
Two other vectors, P and Q. What vector V must be added to two other vectors, and the two other vectors are what? P and Q. Are you getting it now? Or let me see the way you wrote it down.
Added to two vectors.
No, 2, TWO, 2, not 2. TWO, 2, yes, two other vectors. In which P is what? 2I plus 3J and Q is 2I plus 4J to give a resultant. This. Is there any question? Precious, is there any question? Mr. Kukola, is there any question? Is there any question? Okay, good. I want Mr. Kukola thing down. All right. Someone should quickly confirm the answer for us. Add P plus Q plus V if it will give us R. Oh yeah. Add P plus Q plus V. Will it give us R? Add it up.
Yes, sir.
Yeah. That's your solution. Show me your solution. Don't use your head. Show me your solution.
And now, yes, sir.
Yes, Chika, let me see what you did. Okay.
4G, 7G minus 5G, 2G, then this is only 3K.
Good. All right.
Very much.
I'm not sure you're in this class. Subtraction of vectors. Let's quickly write this down.
The second one. So I didn't tell us about the parallelogram. So give us.
Yeah, it's a different person. You don't
know the assignments.
Once you can recite parallelogram law, then I'll now teach you how to use it. Parallelogram law of vectors. All right. Subtraction of vectors. Subtraction of vectors. Though we have done a little bit of subtraction here.
No, say that like, find this like, this I. If you want that parallelogram, can you just, you know, the parallelogram that I know is just one number, there's 3, 4, 5, whatever. But this one is I, J. Find this parallelogram is this. And I'm not going to
Yes, subtraction of vectors. Subtraction of vectors. Subtraction of vectors. Let's just take one example under that. If vector P yes, if vector P equals 2I minus 4J minus 6K. I've been waiting for you. Welcome.
minus 6K.
If vector P is equals 2I minus 4J minus 6K and Q equals, yes, and vector Q, obviously, and vector Q equals 6I minus 3J minus 8K. Hello. Family reunion. Yes, find Q minus P. Find Q minus P. Vector P equals 2I minus 4J minus 6K. Then we have vector Q to be equal 6I minus 3J minus 8K. Find vector Q minus vector P. What's our answer?
4I minus 7J minus 14.
Now, the thing about subtraction is that it's more tricky than addition.
Yes.
Because the minus must open the bracket. Who is watching the live class inside the class? Yes, you are watching the live class inside the class.
You're watching this like watching over here. Okay, 4I plus J minus 2K.
Yes.
What do you guys do?
Hello. Do you know that there's a live class going on?
Yes. Them do.
So you want them to be hearing your voice too?
Yes.
Yes, it's not as if we're
Alright, we are done with that. The next subtopic, magnitude of a vector. Should I do it?
Yes.
Alright. So Q minus P, hello, no noise now. Yes, that's what I want to explain. So we have Q, these are the vectors of vector component of Q. It is in 3 dimensions, X, Y, Z. You know your X and Y axis now.
Yes, sir.
Cartesian plane. But in vectors now, we are using 3 dimensions instead of 2 dimensions. So it is x, y, z. So you now reform it to be I, j, and k. Do you get that now? So we are in subtraction. The addition is just the normal addition. You bring the components, then you add them together. That's all. But subtraction now, there's a different approach. So we have q minus p to be equals 6i minus 3j minus 8k minus p, open bracket, 2i minus 4j minus 6k. So this now will be 6i minus 3j minus 8k minus 2i plus 4j plus 6k. Wow, I like that. So collect items. What do we have? 6i minus 2i, that's 4i.
Minus that plus J.
Plus J, then minus 2k. Do you understand that now? As simple as that. Alright, magnitude of a vector. Ça va bien, merci. Kí ló ṣẹlẹ̀? Can we continue? Alright, I want to rub this side off. Alright. So, remember, what was the, hello? What was the formula I gave you guys for resultant of vector in 3 dimensions? R equals root what?
R1 squared plus R2 squared.
Plus what?
Plus R3 squared.
Plus R3 squared in 3 dimensions. Abi?
Yes.
That's the resultant. Now for vector A, it will now be what?
AX1 AX squared plus AY plus AZK.
These guys, they are just econ genuine. Alright, so now for magnitude of a vector, this is the formula we'll be applying. Magnitude of a vector in 3 dimensions, this is the formula we'll be applying. Example, find the magnitude of, remember, magnitude is what?
Size.
And it is what?
Magnitude is size.
It's size, and it is what? What kind of quantity?
Scalar.
Scalar. It is scalar. That's what I want. It is scalar.
Yeah, like what's the formula for magnitude? They were now like, it's not same when you are like
It's okay. Thank you. It's the same thing. Hello. So now, example 1. Find the magnitude of vector A. Find the magnitude of A to be equals 8i plus 4j plus 8k. So what's the answer? So we have, now for magnitude, this is what we use to represent it. We have two lines like this. Hello? We have two lines like this. So we have this to be equal square root of what? 8 square plus what?
64.
So A, magnitude of A is what?
64 plus 16 plus 64.
And that is what?
144.
So we have root 144, and it is what? 12.
Okay.
Was any SI unit given?
No.
Jesus.
But they give you ID.
No, like something like this.
All right. Hello.
See, after
Multiplication of vectors. Yes, multiplication of vectors. Of vectors. Multiplication of vectors. There are two types of vector multiplication. There are two types of vector multiplication. One, scalar vector multiplication. Scalar vector multiplication. Scalar vector multiplication. And two, vector product. Vector products. Hello. Vector products. Scalar vector multiplication. Scalar vector multiplication. Scalar vector multiplication. Scalar vector multiplication. They are also divided into two. The first one, scalar vector multiplication. I said they are also divided into two. First one, yeah.
Scalar are also divided.
Scalar vector multiplication is also divided into two. The first one is scalar multiplication. scalar multiplication. Scalar multiplication. So under the scalar multiplication, it involves under that scalar multiplication, it involves using a number. It involves using a number or magnitude. It involves using a number or magnitude to multiply a vector in space. A number or magnitude to multiply a vector in space. Full stop. Example. Bọ̀bọ̀ tó ń lá sweet ṣáà ní ilé síta wa. Kó wa lọ sí baby class. So example, hello, Chika. Example, if vector A is equals 3I minus 18J plus 6K, find who's down? And B is equals 2I minus 6J plus plus 2K plus 2K urgent 2K. So find 1 2A minus B. 2 3 into bracket A plus B and 3 4A minus 2B. So how do you go about this?
Start everything by absorb that one.
All right. Yes, now.
Christian done.
Or should we do it together?
No, sir.
Oh, yeah. I'll be fast about that.
What?
You get your answer before.
I've gotten it.
Keep quiet.
No.
Keep quiet. Let us know.
Are you sure?
I do the high one.
You say hi.
Is that it? No.
Minus plus 10K. The minus not open plus and then come.
Hello.
What is
Yes.
Yes, sir. Yes, sir.
That's a lot of money.
Are we done?
No, yes,
Chica.
it's Chica.
Yes. We don't have all day. We don't have all day.
Okay, let's go. I didn't know. Then minus the together.
Ah.
Yeah, no, yeah. I'll be a rush lunch. Minus 36. Oh, what's up?
Are we done? All right, let's do it together. Solution. Hello. Look up. Look up. Suspend that family meeting. Look up. Suspend the family meeting. Look up. And that boy on red check. Suspend the family meeting. Now look at this. We have 2i. Sorry, 2a minus b. So you just multiply these ones by what? By 2, and that is what? 6i minus what?
36J.
Minus 36j plus 12k minus
2I minus 6J plus 2K.
So what do we have?
6I minus 36J plus 12K minus 2I plus 6J minus 2K.
You want to take away this 2k. So 6i minus 2i, we have what?
4I
Then
30J
minus 30j. 10k. What did it? 10k. 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 Alright. The next one. Number 2, we have what? 3 into bracket what? Vector A plus vector B. Now this is same as what? Saying 3 into brackets a plus b, 3i plus 2i, that's what?
5i
5i
minus 24j
minus 24j
plus 8k.
plus 8k. And this is what?
15i
15i
minus 72j
minus 72j
plus 24k.
24k. You know that perfume?
So yes, I did.
That perfume, 24k. You need money.
If you have the money,
Hello. Very nice. Let's take the last one. We have 4a
minus vector b
minus what? 2 multiplied by vector b. So this is what? 4a. 4 times 3 we have a
12i
12i
minus 72j
minus 72j
plus 24k.
24k. No. Then what else again? Minus
4i
4i
minus 12j
minus 12j
plus 4k.
plus 4k again. So if this should open the bracket, what do we have?
12i minus 72j plus 24k minus 4i plus 12j minus 4k.
So what do we have here now?
8i minus 60j plus 20k.
Making 54k, sir.
Plus
20k.
20k. So, all right, let's put that down. Yes, what's your question? 72. 4 times 18.
Yes, you can do.
3 times 24 now.
Actually open body.
A plus B, are we? Minus 18 minus 6 is what? Minus 24. Do you get that now? So once you multiply by 3, you have your what? Is there any magic there? Yeah? Oh, we are going to 72k. Management. Yes, it can be 3a plus 3b. Yes, it's very correct. All right, moving on. We don't have all day. I said under scalar vector multiplication, we have scalar multiplication. Then the second one under it is scalar product.
Vector product.
No, scalar product.
Okay.
Scalar product is different from vector product. Scalar product.
Vector multiplication. That scalar vector multiplication is very good.
Yes.
First one is scalar multiplication.
Yes, the second one is scalar product.
Vector product.
Scalar product.
Right.
This is also called dot vector. Dot vector. Dot vector. Yes, this is also called dot vector. Dot as in D-O-T. Leave him, don't let him write. This is also called dot vector. The scalar product of A and B, the scalar product of vector A and B
Scalar product of vector A and B
The scalar product of vector A and vector B. The scalar product of vector A and vector B is the product of the magnitude. Hello, no noise. The scalar product of vector A and vector B is the product of the magnitude of vector A and vector B.
Product of the magnitude.
Yes, it's the product of the magnitude of vector A and vector B. Full stop. Full stop. It is denoted by, hello, it is denoted by, hello, it is denoted by this. It is denoted by this. By A dot B. Vector A dot vector B. So that's why it's called dot vector. So full stop. The denotation depends on the question given. The denotation depends on the question given. Sometimes it can be vector B and C. So it will be what? B dot C. The following laws holds for dot vector. The following laws holds for dot vector. Number one, Hooke's law call. Fisherman law. So we have this A dot B. The same thing as B dot A. Number two, we have vector A dot vector B.
So that's first one. Is it commutative?
No. A, E, same thing as long as you got B there. Same one. Do what they are doing.
If I don't talk anymore.
So this is what? A dot plus what? A dot C. There's another one. There is more. So this one multiply by this one, and this one multiply by this. Do you get that now?
Yes, sir.
Then the last one, I said there is more. So we have M into bracket A dot B. We have M into bracket what? A dot B, which is same thing as M A dot B, which is also equals to A dot M B, where M is a scalar. Where M is scalar. Where M is scalar. Notes. Note bene. Note what? Note what? Yes, Benin Republic. Note bene. A dot B is equal 0 when theta equals 90 degree or equals pi over 2. Sir? They do pi over 2. I got it. As a shady wobble, dear, anyway. No, am I on that way too? Color purple. So okay, we also have this one, law 4. Law 4. Who sprayed laughing gas in the class? Pay attention. No? So 4, we have unit vectors. For unit vectors, since I, J, and K are perpendicular. Hello, no noise.
I said for unit.
For unit vectors.
For unit vector.
Hello, what's that now?
What's that is?
We have that J dot J is equals K dot K, which is equals I dot I, which is equals 1. If you should laugh again, you go outside. Then if you have I dot J, J dot I, J dot K, K dot J, which other one? I dot K, K dot I. These are all equals 0. Q dot Nikoko. She vibes me. Yes, why is it equals to 0? Babe method. Yes, why is it 0?
Because it is perpendicular.
No, perpendicular. And when you say perpendicular, what's the angle there?
90 degrees.
A 90 degree. And what did I give you in the previous law?
The
when
theta is 90 degrees.
or
Pi over 2. Which is minus.
minus again. Precious. And there are so many precious in the world. All right. One more law. Hello.
One more law.
Five. No noise. If vector A dot B is equal to 0 and vector A and B are not null vector. Are not what? Null vectors. Vectors. Therefore, what's happening between vector A and B? I say if vector A and B equals 0 and vector A and B are not null vectors, therefore vector A and B are what? Are perpendicular. Are what? Are perpendicular. That's what we go there. Are perpendicular. Are perpendicular. No foul words in the class again. Like fagbo. Like you hear that again. Person will go to their house and go and fagbo.
I know.
You want to go to your house and shit, Abby. Type shit.
Family class.
All right. Hello. No noise. All right, that will be all for that. Let's take examples. All for today again. Yes, now. Hello, no noise. I'm giving you one assignment now. Example 1.
Remove your glasses and
Example 1. Hello.
Are you getting?
Everybody stand up. Stand up. Last warning, everybody. Last warning. Don't worry, thank you. So can I rub this up?
Yes.
Example 1. Find A dot B. A dot B. Dot vector B. Find vector A dot vector B. If vector A vector A is equals 3I plus 4J plus 2K. So we have 2I minus 15J plus 8K. So how do we go about A dot B? We have to look for A vector A dot vector B. Yes? Yes. How do you go about it? Yes, Amo Joy will say something now.
So we have, so I think the next example, PI times 2I plus 4D.
All right, let's do it together. No noise. Hello. Pay attention. No noise. So we have 3I plus 4J plus 2K dot what? 2I minus 16J plus 8K. So now, opening the bracket, this one will multiply everything, this one will multiply everything, and this one will multiply everything. No noise. Alright, so 3I times 2I, we have what?
6I squared. So 3I times 2I. 6I squared. Okay. 0.
So we have, hello, 3I times 2I, we have what? 6. I times I is what? 1. 3 times 3I times minus 15I 15J is what? 3I hello. 3I times minus 15J. What do we have?
Okay.
I times J is what? I don't even follow. You are not following it. I times J is what? 0. 0 times the 45 is what? Because 3 times 15 will give us 45, Abby. And that's minus 45. I times J is what? 0. 0 times minus 45 is still what? Abby?
Yes, sir.
3I times plus 8K. On to the next. 4J times 2I. 4J times minus 15J. Minus 60 what? Minus 60 what? Okay. So 4J times 8K. 2K times 2I. 2K times minus 2K times so sum up, what do we have?
Minus 38. Minus 38.
16 and 6 is what? 20 what? 22. So we have minus 38. So vector A dot vector B will give us what? Minus 38. Angle between two vectors.
I'm not done.
Angle between two vectors. Between two vectors. Angle between two vectors. Angle between two vectors. Can I rub up the law now? Anybody teaching you theory of vector and did not mention this? Okay. Theory of vector include. Who said Otifagu now? Oh yeah, outside. Stand up. Go outside. Let me escort. Oh yeah. Can go to Alaba now. I'm going to Fagboni. Go get out. Madam Fagboni Alaba. Hello, no noise. So now, angle between two vectors. Angle between two vectors. Angle between two vectors. The angle between two vectors. The angle between two vectors is gotten by. Is that the road to Alaba? Is gotten by dividing the dot product. Yes, by dividing the dot product. By dividing the dot product of the two vectors. By dividing the dot product of the two vectors. Product by the product yes, by dividing the dot product of the two vectors by the product of the magnitude of the two vectors. This is what I'm trying to tell you. We have cos theta to be equals hello. Go on. You Alaba straight. BRT from garage. Oh yeah. Down for my fair pay. So this is what it's saying. Just write hello. Are you guys with me? Mathematically, write cos theta is equals A dot B over the magnitude of A and B. The product of the magnitude of A and B. So now, no. So now theta can now be equals cos arc or cos inverse of what? All over what? B. Why is it cos instead of sine? In your Cartesian plane, Which one is more relevant?
So what is that?
No, your Cartesian plane.
Oh, excuse me.
X and Y axis. Which one is more relevant? We have two dimensions there, Abi, in your Cartesian plane, and that is what? X and Y, Abi. Now, why resolving to angles in y-axis? What do you use? Why resolving in angles in x-axis? What do you use? You have something like this. X and what? Y-axis, Abi. Why resolving vertically? What do you use? This is y-axis. If you are looking for any angle in y-axis and you are looking for any angle in x-axis, what do you use? That's what I'm asking.
X is sine and Y. X Y is
Assignment 2. Take that as assignment 2.
Cheetah. Why did you ask me?
Assignment 2. Good evening, man. You know me. Hello, you know me. Before we start any class, we'll treat the previous assignment. So me giving you as an assignment is a way of what? Engaging you. Assignment. What angles do you use to resolve for y and x axis?
It's okay now.
Come. Hey, Alaba! Come and do Osha here. Let him do Osha. Come. Put the book here. And do Osha. What angles do you use to resolve for horizontal and vertical axes in the Cartesian plane? What angles? Continue, pressure. Follow close up. What angles?
Please, sir, just give.
What angles do you use to resolve for horizontal and vertical axes in the Cartesian plane or on the Cartesian plane? Vertical axis.
On the horizontal.
Yes, ma'am. Cartesian plane.
On the Cartesian
I'm not Jesus. I don't come again. What angles do you use to resolve for horizontal and vertical? Come back. Stay there, Joe. So now let's take a question. Hello, a question.
Yes, sir.
Find the angle. Hello. Next class, we'll be moving straight to resolution of vectors.
Yes, sir.
There are other things, so many things I can still teach you, but don't let us bore ourselves with that. Let's move to the cocoa of the matter. Alright. Find the angle between vector A. Questioner. Find the angle between vector A. Vector A, which is what? 3I plus 2J minus K. And vector B, which is equals 4I plus J minus K.
Okay, sir.
You are advertising per students there. So should we do it together?
No, sir.
All right.
Which one is yours, sir? Stop this for us.
This is the formula. Find the angle. It's as simple as that. Omo Joibo, you have done your part. You just wrote down the question, abi? Who is Jonathan? Ebele ni. So now, hello, pay attention. So A dot B, what you first look for is what? A dot B, and this is what?
That is 3 times 4.
3I plus 2J minus K, having dot 4I plus J minus K, having. So what do we have? This is what? 12 plus 2 plus 1, having. So what do we have? This is what? 15, having. Now you look for the magnitude of A and B. Of A, what do we have? Square root of what? Square root of 3 square plus 2 square plus minus 1 square, and this is what? Root 9 plus 4 plus 1, and this is what? 14. So this is what? Root 14. Then what do we have? Magnitude of B. Square root of what? 4 square plus 1 square plus minus 1 square. So what do we have? 16 plus what? Plus 1 plus 1. This is what? Root 18. So from there we can deduce that our theta is equals cos arc or cos inverse of what? 15 over what?
3.74
root 14 times what? 18. Abi, according to your third law, this is possible, Abi? Is this possible?
Yes, sir.
Root 14 times 18 is what? So just 252. 252, Abi? Okay, root 252. So we have what?
Okay, then.
Shift cos. Cos of what? 0.89 what? 945. So theta is what? Theta is equal 19.1. So approximately we have 19 Degree. This is the angle between the two vectors. Before uncle, don't joke with it. Take and play first. Assignment. Now this one is general assignment. General assignment. All those ones they are preamble area. Hello, set it down. No noise now. You guys are just disturbing. Now, assignment.
Assignment, guys.
Can I rub this off?
Yes, sir.
Where did you go to?
She's learning skills.
Assignment. Hello. Number one, if vector A is equals 3I plus 4J minus K and B equals I minus J minus K and C equals 2I minus 2J plus 4K. Hello, no noise. It's the same thing. No noise. I went to borrow C on our place. Pay attention. Find I. 2A plus 3B minus C. 2 into brackets A plus B minus C. Let's put 4C. 4C minus 4C. 3 5A minus B dot C. Number 2. Find the angle between vector R. Yes, it's good. Band down. And S is equals 4I So this is where we call it a day. So, hello. Ẹ tẹ̀ jẹ́ kí àwọn tó wà ní live gan enjoy class. Hello. No noise. So please like, share, comment and subscribe. End the class. End the class.